So I'm not going to go with details. I will go, division means not details, you know. First, what is rotational motion? In the book, yes, your book starts defining by rotational motion, in fact, even though I went in details with the circular motion, because most problems are about circular motion, but the book's definition starts with rotational motion. Yeah, when an object spins, it undergoes rotational motion. Spins, rotates, it undergoes rotational motion. And as an object is rotating, it rotates about a specific point. Yani, it's the point where the object is fixed mostly. And the line which passes through this point is named as axis of rotation of this rotational motion. And in rotational motion, axis of rotation will be, as I said, passing through the fixed point. And generally this point is going to be on the bulk of the body object, yani at the center or in here, like that. But in circular motion case is a bit different. In circular motion, x rotation will pass through the center of the circle. So x rotation of the circular motion passes through the center of the circle, but rotational motion, we cannot be precise about this. It can pass through any point about which object rotates. Generally, that point is from where you are going to fix this object. And in the book, Ferris wheel is an example is given. Ferris wheel is in rotational motion because it is spinning in its place. While it is spinning in its place, it is in rotational motion. And then we are going to define rotational rotation for the rotational motion. So the line about which rotation occurs, yes. From where did we fix the Ferris wheel? We fix it from the center. Now this time, because we fix it from the center, x rotation passes through the wheel's center. And also, when we check this line which passes through the center, we are going to see that this line is perpendicular to the surface. That's why it is that line perpendicular to side, yani surface of the Ferris wheel and passing through the wheel's center for Ferris wheel. Ferris wheel is in rotational motion, but as Ferris wheel is in rotational motion, we are going to observe that the light bulbs or cars or cabins, they are following a circle. They are in circular motion. Yani, object is in rotational motion, but the points on this object, they are going to be following circles. That's why we are going to say that they are in circular motion. Light bulbs are in circular motion. Cabins are in circular motion. Or a person sitting in this car will be following the circle in circular motion. But whole combination, which is, we say, Ferris wheel, is going to be in rotational motion. And rotational motion generally defined by some keywords. One of them is rotate, the other one is speed. Rotate and speed. Circular motion defined by some keywords. One of them is revolve, the other one is orbit, and also travel. So these three are the keywords for circular motion. These three are keywords for rotational motion. Yeah, when a statement is done by these two words, so this statement talks about rotational motion. If statements are done by these keywords, they are talking about what? Circular motion. Right. You also already observed that this chapter basically about circular motion. So that's why we are going to define circular motion in details compared to rotational motion. In chapter 2, we are going to mostly deal with rotational motion. So if an object moves in a circular path, so we can define this motion by some specific terms. One of them is moving, traveling once, one time, twice, two times, triple, three times, four times, five times. It goes on like this. Once, twice, three times, four times, five times, times. Turns, you saw all have the problems. Turns, one times turning, two times turning, turns, same thing. Or if we are talking about the circular motion, about this revolution. Revolution in circular motion completes one revolution. In rotational motion, rotations. And as object is moving in circular path, it completes one revolution, and this one revolution travels a distance which is equal to circumference of the circle. And at the same time, this object turns an angle which is equal to an angle which is 2 pi radian or 360 degrees. But if object moves not complete circle, a part of the circle, we can also define a relation between these three quantities. Because in full circle, distance traveled by the object is 2 pi r. Angle turned by the object is 2 pi. If I divide this 2 pi r, which is s, by angle theta, which is 2 pi, what do we get?
Radius.
Radius. So the same equation also can be written for any part of the circle, not only full circle. So if I divide this arc length, which we name as, and my angle, we are going to get the radius of the circle. Or if we rewrite this equation, theta is going to be s over r. Yeah, if I want to write angle in radian, I have to divide this arc length in the circular path by the radius of the circle. So I will get how much angle the object turns. Yani, if an object moves along a part of the circle which is called arc, it travels a distance which is equal to s, and it is a linear quantity because it's measured by meter, centimeter, kilometer distance. It also turns an angle theta, and these three quantities are related by equation. Theta is equal to s divided by r, or r is equal to s divided by theta. And in this division, when we divide arc line by the radius, we get angle, but this angle is going to be in radian, not in degree, because radian is the SI unit which we use in measurement of angle. And then we are going to find radian. Radian is a pure number with no dimension. Why pure number with no dimension? Because according to the equation, s is equal to s over r. S is arc length, its length. Radius is also length. So when we divide length by length, so they will, so only a number. That's why this is a number, only number. But 1, 2, 3, 4, 5, it's a number, but not only radian is a number, a degree is also a number. So what are we going to do? We are going to add this quantity named as units. 1 radian, 2 radians, 3 radians, to separate it from degree. It's a pure number with no dimension. It is a radian, but 1 radian is spatial angle. Why spatial angle? Because this is the only angle whose arc length is equal to its radius. So here is, as you see, if this arc length and that radius of the circle equal to each other, then this measure of the angle is going to be 1 radian, which is 57.3 degrees, which is the missing question. 1 radian is the angle whose arc length is equal to radius. Or 57.3 degree is the angle whose arc length is equal to radius of the circular path. What if it is 2 radian? It's not spatial one. If it is 2 radian, which means it must be twice, huh? then arc length should be twice of the radius. Because if this is S, this is R. If I want to get the result 2, S must be 2R. 2R divided by R is how much? 2. If 3 radian, arc length should be 3 times of the radius. 4 radian, 4 times of the radius, and so on. And in some questions, you are going to see the choices will be given in radian. In some questions, choices will be given in degree. So then we have to know how to convert degree to radian, radian to degree, or other measurement on circular motion, revolution. Also a measurement of the angle in a different way. How to convert revolution to radian, radian to revolution, degree to revolution, revolution to degree, or what? So we are going to use the measure of one circle or half circle and semicircle. The measure of one circle is how many radians? 2 pi. At the same time, it's equal to 360 degrees. This is equal to 1 revolution. Measure of 1 revolution, 1 circle. Half revolution is what? 180 degrees. Yani pi 3.43. You can use any of them for conversion. Because this one is a simple, much simpler compared to 2 pi, but generally in the book this is given as a equation. Pi radian is equal to 180 degrees. Then you are going to say that any given angle in degree is equal to how much? In radian, for example. And in the book, I think it was, how many radian, it was degree was given, 30 degree was given, I think. So, then you are going to say that pi radian is equal to 180 degrees. Then 30 degrees is equal to how much angle in radian? Then you are going to continue with the cross product, and you will find how much is the angle. Then angle in radian times 180 is equal to pi, which is, you can live by pi or you can write 3.14 depending on the choices. Pi multiplied by 30 and simplify 180, simplify 180. So you can go simplification. 3 pi over 18 radian. We wrote by this way too, if the choices are given pi. But if no pi, what should we do? We are going to write in here 3.14, 3 times 3.14 divided by 8. This is one of them. We can use the 1 revolution measure, half revolutions measure, or we can use definition of 1 radian. What is 1 radian definition? 1 radian is equal to how many degrees? 57.3 degrees. Then any given angle in degrees is equal to how much in radian? Again, cross product. We can do it this way and that way. Both are cross product. And one more method is using the equation in the book. So we can get this equation from this cross product also. How? Angle in radian times 180 degrees equal to what? Pi radian multiplied by angle in degree. Then I'm going to simplify by 180, divide by 180, so we will get this equation. So can we also write this equation by using 1 revolution measure?
Yes.
Yes, we can. So in here you are going to write 2 pi, but the denominator is going to be 360. Did you get that this is 1 revolution, this is also 1 revolution? But in different scale. One of them is in radian, the other one is in degree, but they are equal to each other. Or if no pi over 180, numerator is half revolution in radian, denominator is also half revolution in degree. How? Which one is going to be in numerator, which one is going to be in denominator? Depends on what are you going to convert. If you will convert, if you convert degree to radian, you have to cancel degree. How can we cancel degree? In numerator. Okay, so then denominator must be. So then this degree and this degree will cancel. You will get result as radian. But if radian is given to you, you will convert it into degree. This time radian should simplify. That's why denominator must be radian. Degree must stay. So by this way you can get it. Pi over 180 or 180 over pi. Okay, so this is how we convert them each other. If a question I'm going to show, then after that I will continue the next part. One revolution, how many radians? 2 pi radian, correct? Is it only 2 pi?
No, it's also 6.3.
Yes, this is one of the most incorrect answered question last year. 2 pi, very nice. Circle A, B, but what about C? C is also correct, and both B and C is correct, are correct. 4 radian, how many revolutions? 1 revolution, how many radians? 2 pi. 4 radian, twice. Or radian to revolution divide by 2 pi, yeah, 6.28. So if angular displacement in revolution is equal to angular displacement in radian divided by 2 pi. And how much is the in radian? 4 pi. 4 pi divided by 2 pi, they will simplify result is 2 revolutions. You can get from mine, but also you can use by equation. 1 degree is approximately how many radians? Yes.
57.3.
It's wrong. 1 radian is equal to 7.3 degrees. 1 degree is equal to how many radians? C is the correct answer. 1 degree is equal to C radians. So how can we get it? How can we get it? I can use any of the definition. Half circle, half revolution. So half revolution. How many degrees? 100. How many radians? 3.14 radians. So 1 degree. How much angle in radian? Find this. Then delta theta times 180 is equal to 1 times 3.14. So divide both sides by 180. You will get delta theta as C. Is the answer. Okay, this then. Angular displacement. Next title. But a displacement is defined according to a reference point in the 11th grade, reference line in 12th grade. Because we define circular motion by angle. An angle can be defined by between 2 lines. That's why we have to use reference line. Reference line starts from the center of the circle, passes any point you want. Then you can define the position of any object with respect to this reference line. For example, I put the bicycle in here, but let's say that there is no bicycle. Initial the bicycle in there. We draw a bicycle. Okay? Is it a good drawing? Okay. So, initial position of the bicycle is what? This is the initial position. So let's determine this initial position by an angle. Theta 1 or theta initial. The bicycle will start moving from this position to another position. Let's move the bicycle. This distance the bicycle traveled, what did we say? Delta S. Or S, just S in mathematics and physics, delta S. And now this bicycle will have a new position. Let's define the bicycle's new position in terms of angle. So from where we are going to draw the angle? From reference line. From reference line until where the bicycle is. Final position. The bicycle is in here. This is theta 2. How much is the angular displacement? How much is the angle the bicycle moved from this position to that position. This is delta theta. And we know how delta S, delta theta related. Delta theta is equal to delta S over R. We put delta in physics because if an object is in motion, it's changing. And what about delta theta? Can I write delta theta in terms of initial position angle and final position angle? Why not? In the 11th grade, you wrote this in displacement, in linear displacement, delta x is equal to x2 minus x1. Why don't we do the same thing in angle? Delta theta, theta 2 minus theta 1. In one of the questions, the test one was about this. Okay, so angular displacement is the angle through which an object is rotated in a specific direction. And this angular displacement delta theta is calculated by delta S over R. And these directions can be clockwise or counterclockwise depending on, it can be positive or negative depending on the direction of rotation, clockwise or counterclockwise. And also, every one revolution, every one rotation is defined as 6.28 radian in angular displacement. It doesn't matter what is it. Anything which rotates one time or any object which revolves one time has an angular displacement 6.28. This is just one the one which we did the test one. Okay, so the rest of them is unpacked all the out, so you can do it. Then angular speed. Angular displacement. In angular displacement, we don't care how object turns. What we care is where is the initial position, where is the final position, how much is the measure of the angle between them. So the angle from one position to another position. How object moves from this position to that position quickly or slowly, it doesn't matter for us if the measure, regarding the measure of the angle. But speed, how quickly object moves from one position to another position, it matters for us in speed. That's why speed is how quickly an object moves from one position to another position. So if a definition starts with how quickly, a statement starts by the rate. The rate. That's why angular speed definition starts by the rate. But what is changing how quickly? Angular displacement. How quickly it changes. The rate at which a body rotates about an axis. Or rate of rotation. Or time rate of change of what? Angular displacement. So then, if definition starts by the rate, I also said that absolutely the denominator is going to divide it by delta t. Now, what is changing? Time rate of what? Angular displacement. Yani delta theta is going to be equal to omega average. And that's why we say that the angular displacement, angular speed is the ratio of angular displacement to time interval delta t. Its unit is radian per second. And clock questions are maybe the most important question in angular displacement. Angular speed title. Second hand, fastest. Minute hand, in the middle. Hour hand is the slowest one. Second hand completes one rotation, yani 6.28 radian in 60 seconds. Minute hand completes one rotation, yani 6.28 in 60 minutes. Convert to seconds, 6 times 60, 3,600. Hour hand of the clock completes one rotation in 12 hours from 1 to 12. So 12 hours converted to second. 12 hours, every 1 hour is 60 minutes, every 1 minute is 60 seconds. So 12 times 60 times 60, which is going to be 40 to 200. 600? 290, 43,200 was the answer. So where do we use them? We use them in calculation of the angular speed. For example, what is the angular displacement, angular speed of second hand? Then I'm going to use omega delta t over delta t. What is the one rotation measured in radian? 6.28. What about time for one rotation? 60 seconds. And when you divide them, you will get the angular speed of the second hand. Or for minute hand, one rotation takes how many minutes? So then we are going to write 6.28 divided by 60 minutes, but in seconds, 3,600. You will get radian per second. Can we get the unit? Can they give the unit radian per minute? Why not? They can give choices as radian per minute. In this case, you should use time interval as minute, not second. That's why I said them first. Check the choices first. These are the questions about them. Okay. And this question is one of the popular questions in ministry. If a cyclist rides along a circular track, if the cyclist travels around exactly half the track, half the track means half revolution. It's talking about angular displacement. 1/2 revolution, half the track. This happens in 10 seconds. So what is average angular speed in revolution per second? This time it's asking. If it is asked revolution per second, I have to use angular displacement in revolution, not in radian. So what I have to do? So what is angular displacement in revolution? How much? 1/2 delta t. Is it 10? So it's going to be 1/20 revolution per second. So it's going to be this part is changing. Sometimes in some questions it is 1/4, quarter. In one question 3/4. 3/4 means 3/4. 1/4 means 1/4. All are revolution. But if choice were given radian per second, what should we do? We are going to multiply this by 6.28. Only multiply by 6.28. You will get result as radian per second. A car tire rotates with an average angular speed of 12 radian per second. How many times does the tire rotate in 2 minutes? What is this how many times rotates? How many times? What is this asking? Delta theta. Delta theta. Times. Remember times, turns, revolution, rotations, all have equal displacement, equal angular displacement 6.28. So get the angular displacement first radian, then convert it to times by dividing 6.28. So omega average is equal to delta theta over delta t cross product. Delta theta is going to be omega times delta t. How much is omega? 12. Delta t, 2 minutes, of course, we should write it in second because this is given in second, this must be in second, and they must be same unit. So then 2 minutes, 120. How much is angular displacement in radian? 1,000?
Option A.
Sorry?
1,140.
140. This is radian, huh? So then divide by 6.28, you will get how many times? Divide by 6.28, this number. Pardon, you divided already.
Yes, exactly.
Are you sure? Maybe so when you multiply this to, is it 1,000? No.
6.28.
Multiply 12 by 100.
229, sorry.
200. When you divide by 6.28, you got?
229.
Yeah, this is the correct answer. You saw that? I put here times. Yani if you don't care about the units, it's going to be the wrong answer. This is radian, this is times. Yani revolution, rotations. Okay, you should be careful. Okay. This one is very similar one, the one which we saw. Then angular displacement, angular acceleration. So what's acceleration? Acceleration is calculated if angular speed changes. If angular speed changes. Linear speed also calculated the same way. If linear speed changes, we calculate linear acceleration. In section 2 we did this. But if angular speed changes, we calculate angular acceleration. So this is the equation. We're calculating angular acceleration. Find, how can you find the change? Final value minus initial value divided by time interval during which this change happens. Yani omega final minus omega initial divided by delta t, which is delta omega over delta t is the alpha average. So unit of average angular speed acceleration is what? Unit of angular speed, radian per second. Divide once again second, radian per second. Okay, these are some questions which you did incorrect. Okay, in the test one last year, not you, last year's students. Okay. A hamster gets on a stationary wheel. What does stationary mean? Initial angular speed is 0. With a radius of 0.15. If needed, I'm going to use. Runs until the wheel rotates at an angular speed of 1.91 revolution per second. This is final. What? Revolution per second. So choices are important. What is the average angular acceleration of the wheel? What choices are given? Radian per second. So I shouldn't go with this. I have to find this by multiplying 6.28. So then it's going to be how much? Multiply it, omega final. How much? 11.9 radian per second. Now we can go with angular acceleration equation, omega final minus omega initial divided by delta t. Omega final is how much? 11.9. Initial is 0 divided by delta t, which is result is going to be 2.96 radian per second squared, yani C. Okay. You can find this. This one is tricky a bit. If the angular speed of the object changes from 15 revolution per second to 2.5 radian per second, average angular acceleration of the object is going to be positive, negative, or 0. How can we find alpha? Good. So, if omega final minus omega initial divided by delta t, if omega final is greater than omega initial, what does it mean? Alpha is positive. If omega final is equal to omega initial, you understand? Alpha is 0, constant, 0. If omega final is less than omega initial, alpha is negative. Now, this is omega initial from. This is omega final. Which one is greater? Huh?
Omega is greater.
But this is 2.5.
But it's in radians.
Yes, this is revolution per second. We should make them same unit. So then I am going to now first do one of them, convert one of them to another one. So 1.5 revolution per second multiplied by 6.28, it's going to be 9.42 radian per second. This is omega initial. Omega final is less. So omega less than, then it's going to be negative. So angular acceleration should be negative. Okay, this is angular acceleration. And kinematic equations. Let's remember them all. First equation, first two kinematic equations were this. One of them is coming from definition of angular acceleration. Omega final minus omega initial divided by delta t cross product. Then we will get this equation. I said that they are the same. equations. Only we are rewriting equation that way. Second one was coming from definition of average angular speed. It was delta theta 1 over 2 omega initial plus omega final times delta t, and I said that this is average angular speed for an object whose speed is changing uniformly, regularly, yani constant angular acceleration. Constant angular acceleration means angular speed should change regularly or uniformly. So this equation is the second equation, which calculates delta theta in terms of by using what variable delta t. This calculates final angular speed in terms of delta theta. And third equation is again angular displacement, and these two equations are combination of first two. Omega initial delta t 1 over 2 alpha delta t squared, and last one is omega final squared is equal to 1 over omega initial squared plus 2 alpha delta theta. The last equation is a special one because in this equation no delta t. So angular speed changes in terms of what? Delta theta is the variable, and omega final changes when object is rolling. Let's check. Okay, by the time in here omega initial and omega final, they are instantaneous angular speeds, which means angular speed belongs to initial instant, omega final angular speed belongs to final instant. So this is the test bank question. Delta t is equal to 1 over 2 omega initial plus omega final delta t. And here omega initial represents what? Average angular speed, instantaneous angular speed, instantaneous angular acceleration, instantaneous angular displacement.
Angular speed.
Yes. Zaten böyle bir şey yok bizim şeyimizde. Instantaneous angular acceleration. If angular acceleration changes, this happens, but we are studying only constant angular acceleration. Okay. What is the angular displacement of spinning amusement park ride? It accelerates from 0.5 radian per second, which is omega initial from. And a constant angular acceleration is 0.2 radian per second, which is alpha, for 10 seconds, which is delta t. What is angular displacement? Delta theta. So I'm going to calculate delta theta. Initial is given, alpha is given, delta t is given. As soon as I see that, I remember which equation? Third one, because third one fits. So delta theta should exist. So this one, impossible. Yeah, in here we have delta theta. In here we have delta theta. In here we have delta theta, but the rest of them should be known. In the first equation we have also omega final. Initial is known, but final unknown, so not possible. In here, again, omega final is also unknown, not possible. And third one fixed. Initial is known, delta t is known, alpha is known. So we are going to use this equation. Delta theta is going to be omega initial 0.5 delta t plus how much is delta t? Sorry, how much is delta t? It is 10 seconds. We are going to write 10 plus 1 over 2 alpha 0.2 times 10 squared. So this is going to be 5 plus this is going to be 100 times 0.2, which is going to be 10 addition 15 radian, but choices are given in. There is radian, but there is no correct radian answer. So we should check also revolution. So divide by 6.28, convert revolution. 15 divided by 6.28? 2.4. Yeah, one of them is it 2.4? Are you sure? Yes, 2.4 revolution, because I changed later this question. It was mistyped last year. In your test findings, it's correct.
Yeah.
And what is the angular displacement of wheel on upside down bicycle in 6 seconds, which is delta t? If the wheel's angular acceleration is 0.5 radian per second squared, and initial angular speed is 2 radian per second. Alpha is given, delta t is given, and delta theta is asked. Which equation fits? Again, third one again in here. Third equation fits. Because delta theta is the question, initial is given, delta t is given, alpha is given, so third one. A car wheel is rotating at 100 radian per second, undergoes a constant negative acceleration. A car wheel is rotating. So this is initial angular speed. Then constant, but be careful, you should write this one alpha as negative 6.66 radian per second squared. Even though in the question it is positive, but it says when the brakes are applied, what is the angular speed? The car starting after 12 seconds. Delta t. So what is the angular speed? Omega final. So what is given? Initial is given, final is question, delta t is given, and alpha is given. First equation fits, yes. Omega final will be calculated, so unknown. In here we have omega final. In here we don't have omega final. In here we have omega final. So omega initial is given. Yes, alpha is given. Delta t is given. First one fits. Second one, delta theta is also unknown, huh? Also in here delta t is delta theta. Sorry, not delta theta. Delta theta unknown, so two unknowns. So we are going to write in the first equation, and we are going to find the answer. And I think we are going to finish only section 1, huh? Yes, it's also okay. Now later we go with section 2. We already did the section 2. You are fresh in section 2. You are fresh for everything. It was 2 weeks, huh? And this was important. 2 weeks. Rotating object stays rigid. What does rigidity mean in physics? Object shape doesn't change while it is rotating. So, if object shape doesn't change while it's rotating, like this disc, when one of the paper in here, colored one, which is orange and pink, when one of them completes one rotation, other one also completes one rotation. Let's check it. This, I'm just looking this orange one, then you check pink one. Orange one will complete one rotation. One revolution, sorry. What about the pink one? Same. It doesn't matter how many paper you insert in this disk, you will observe the same thing. That's why angular displacement of all points on this disk should be same. But if angular displacements are the same, these angular displacements are happening at the same time, so that's why angular speeds must be same. And if angular speeds are changing, same in the same time interval, angular acceleration should be the same. Yeah? For a rigid object, all rotational quantities of different points should be the same. But if not the same, in this case you are going to say that this object is not rigid and its shape would be changing. Angular speeds could be different, angular displacements could be different, or angular accelerations might be different. In this case, we are going to be then say that this object might be not rigid. Okay.